Seriously, it's all around you. Have you ever wondered why bread rises in the oven, or how soap gets your hands clean, or why the sky is blue? The answer to all those questions and so many more is chemistry. Chemistry isn't just something that happens in a laboratory with people in white coats and funny-looking goggles. It's happening all around us all the time. It's happening inside your own body right now. The air you breathe, the food you eat, the water you drink, it's all chemistry. Understanding chemistry is like getting a secret instruction manual for the world. It helps you understand how things work, from the tiniest particles you can't even see to the giant stars in the night sky. It's a fundamental science, the science of matter and what it does. Think about making a cake. You mix flour, sugar, eggs, and baking powder, you put it in a hot oven, and poof, you get a delicious fluffy cake. That's a chemical reaction. The heat causes the ingredients to change and combine in new ways. Or consider a rusty old bicycle. The metal of the bike frame reacts with oxygen in the air, creating a new substance, rust. That's another chemical reaction. From the batteries that power your remote control to the fireworks that light up the night on the 4th of July, chemistry is the science behind the scenes, making everything happen. It's not just important, it's essential to our everyday existence and our technological world. When you start to learn chemistry, you're not just memorizing facts from a book, you're gaining a new perspective on the world. You begin to see the connections between things you never noticed before. Why do we add salt to icy roads in the winter? Chemistry. How does a plant turn sunlight into energy? Chemistry. It gives you the power to ask why and how about the world, and then go find the answers for yourself. This curiosity is what drives science forward. So, you're ready to dive into the world of chemistry? That's awesome. But where do you begin? Just like you can't build a house without a foundation, you can't understand the cool explosive stuff without learning the basics first. The first thing on your list should be the atom. Everything is made of atoms. They are the fundamental building blocks of all matter. You'll want to learn about their parts: protons, neutrons, electrons. Understanding how these tiny particles are arranged and how they behave is the key to unlocking everything else in chemistry. It's the absolute ground floor of our chemical skyscraper, so it's the perfect place to start. Once you have a good handle on atoms, the next logical step is to learn about the periodic table of elements. This amazing chart is like a cheat sheet for all the known elements in the universe. It organizes them based on their atomic structure and properties. Learning how to read the periodic table is a superpower. It can tell you an element's atomic number, its symbol, and help you predict how it will behave and react with other elements. You don't need to memorize the whole thing right away, but you should get familiar with the first 20 elements like hydrogen, helium, carbon, oxygen, and understand the general layout of the table. Next up are chemical bonds. This is where the action really starts. Atoms rarely like to be alone. They prefer to hang out with other atoms. Chemical bonds are the forces that hold atoms together to form molecules and compounds. You'll want to learn about the main types like ionic bonds, where electrons are given or taken, and covalent bonds, where electrons are shared. Understanding bonding helps explain why water, H2O, has the properties it does, or why table salt, NaCl, is a crystal. It's the how behind the way matter is put together, turning individual atoms into the millions of different substances we see around us. Alright, we know what to learn, but how do we learn it? Let's use a step-by-step method that works for any topic, whether it's the atom or a complex chemical reaction. The very first step is to get a big picture overview. Don't dive straight into the tiny, complicated details. Before you try to understand the quantum mechanical model of the electron, just watch a short, simple video, or read a basic introduction that answers the question, what is an atom? This initial pass gives your brain a framework to hang all the future details on. It's like looking at the picture on the jigsaw puzzle box before you start trying to fit the pieces together. Step 2 is to identify the key vocabulary. For our atom topic, you'd make a list of words like proton, neutron, electron, nucleus, atomic number, atomic mass. You can't understand the explanation if you don't know what the words mean. So take the time to define each of these key terms in your own words. Don't just copy the definition from a book. Rephrasing it helps your brain process the information and proves that you actually understand it. This vocabulary list becomes your personal chemistry dictionary for the topic. With the big picture and vocabulary in hand, step 3 is to dig into the concepts one by one. Now you can focus on the details. Spend some time just on the nucleus. What are protons and neutrons? What are their charges and how do they stick together? Then, move on to the electrons. Where are they located and what is their role? By focusing on one small piece of the puzzle at a time, you prevent your brain from getting overwhelmed. This methodical approach ensures you build a solid understanding before moving on to the next, slightly more complex idea. The final step in our process is to connect the concepts back together. How does the number of protons, the atomic number, relate to the number of electrons in a neutral atom? How do all the parts, protons, neutrons, and electrons, come together to give an atom its overall properties and mass? Draw diagrams, create concept maps, or try to explain the entire topic to a friend, or even your pet. This step solidifies your understanding and transforms a collection of separate facts into a cohesive piece of knowledge. Learning all these new facts and concepts is one thing, but how do you make them stick in your brain so you can remember them for the test and beyond? Your brain is an amazing machine, but it needs a little help. One of the best ways to remember things is to use mnemonics and silly associations. These are memory tricks that connect new information to something you already know. For example, to remember the difference between cations and anions, remember that Ca+ ions are positive ions, which means anions must be the negative ones. The sillier and more visual you can make the association, the better it will stick. Another powerful technique is to actively recall the information. Don't just reread your notes or the textbook chapter over and over again. That's a very passive way of learning. Instead, close the book and try to write down everything you can remember about a topic, or even better, pretend you have to teach the concept to someone else. Stand in front of a mirror or an empty room and explain what an ionic bond is, out loud. This process of active recall forces your brain to retrieve the information, which strengthens the neural pathways and makes the memory much stronger and more permanent than just passively reading. Spaced repetition is another brain hack that scientists have shown to be incredibly effective. Instead of cramming for hours the night before an exam, study a topic for a short period, then take a break. Come back to it the next day, then a few days after that, then a week later. Each time you review the material, you're telling your brain, "Hey, this is important, don't forget it." This method of spacing out your study sessions is far more effective for long-term memory than one single, massive study session. There are even flashcard apps that use spaced repetition algorithms to automatically show you the facts you're about to forget. Finally, connect what you're learning to the real world. Abstract ideas are hard to remember, but stories and real-world examples are easy. When you're learning about acids and bases, don't just memorize the pH scale. Think about the lemon juice, acid, that you put on your fish or the baking soda base you use to bake cookies. When you learn about polymers, think about the plastic water bottle you're holding or the nylon in your jacket. By linking the chemical concepts to tangible things in your everyday life, you give your brain more context and more hooks to hang the information on, making it much easier to recall later. To become a master of chemistry, you'll want to use every tool at your disposal. And I'm not just talking about fancy lab equipment. Simple, desk-ready tools are often the most powerful. Flashcards. Old-fashioned, but they work. Create flashcards for vocabulary words, element symbols, polyatomic ions, simple formulas. Writing them helps memorization. Carry them and test yourself when you have a spare minute. Waiting for the bus, standing in line, during a commercial break. Perfect for active recall and spaced repetition. Visual aids are super-powered for visual learners. Don't just read the atom, draw it. Draw the nucleus, the protons, the neutrons, the electrons in their shells. Use different colors. Learn molecules with a model kit or gumdrops and toothpicks. Hold a 3D water molecule to feel its shape and polarity, instead of just seeing H2O on a page. Make posters of the periodic table or reaction pathways and hang them where you'll see them every day. Experiments are essential. Doing science is the best way to learn science. You don't need a full lab. Try safe kitchen experiments. Make a baking soda and vinegar volcano to see gas production. Baking soda =, base, vinegar =, acid. Dissolve salt and sugar to study solutions and solubility. Leave steel wool in damp air to watch oxidation, rust, over time. These hands-on activities make concepts unforgettable. Always have adult supervision for experiments. Finally, group study is powerful. Study with a friend or small group. Quiz each other. Take turns explaining concepts, work through tough problems together. A classmate's perspective can make it click. Teaching others tests your knowledge. If you can teach it, you know it. Keep the group focused. Flashcards, visual aids, experiments, study groups. Turn learning into an interactive, engaging adventure.